Hello, welcome to lab report number 10, Semiconductor light source. I'm Diego.
I'm Tyler.
And our TNM is still at lights. So this is the outline of the experiment. Part A, physical properties of LD and LED. Part B, spectra of LD and LED. Part C, beam divergence of LD and LED. And part D, power output versus drive current for LD and LED. So for the theory, LDs and LED are physically components in the system. This means that they have measurable quantities such as area and cavity size. With a precise enough imaging system, these can be measured. So that was the setup for part A. We got the microscope and the computer that was attached to the camera to record the data.
So for part A, this was the laser cavity we took and the red LED along with pixel measurements. And this was the green and blue LED also with pixel measurements. So here was our data. So 1 millimeter in our measurements was 418 pixels. So we found the measurements of each of these in pixels and then converted to millimeters or millimeters squared. We found the longitudinal mode spacing to be 330 gigahertz, which is typical for this laser setup. The laser cavity size and the LED areas were also typical and conformed with expected values.
So for part B, LD output spectrum can change depending on the relative current. Few main regions can be observed: below drive current, at drive current, and above drive current. So this was a setup. It was a basic setup with the integrated sphere and the DMM and a laser diode.
So here were some of our spectrographs for part B, and then here was the LED spectrograph for part B. So by summing the reciprocals of two consecutive peaks, then multiplying by C, we could find the spacing. Our two peaks were at 672.1 and 672.5 nanometers, which gave us a result of 265 gigahertz, which was very close to the 330 gigahertz from the previous part.
So part C theory for the LED and LED, rotating the angle of the source and changing a polarized rotation could affect the power. So that was a setup with oscilloscope, function generator, amplificator, and optical components in the detector.
So this was our graph for power versus angle of the polarizer for the LED, and this was the one for the laser diode for both the major axis and minor axis. For the LED and LD polarizer ratios, it was close to 1 for the LED, which is expected, and very small for the laser diode, which is expected due to their polarization states. The laser diode also decreased off-axis much more quickly when the minor axis was parallel instead of the major axis, and they also formed the observed cosine squared pattern.
Power output does not always increase in area with drive current for part D, the theory. So that was set up for part D, which is exactly the same as part B.
So these were our two graphs for LED power output versus current and LD power versus output current. As you can see, there are two major states here, before the threshold current and after the threshold current. For the laser diode, we observed the threshold current to be roughly 20 to 24 milliamps. And then we can also see it here where the laser diode did not increase until we hit that threshold current and then did afterwards, while the LED increased linearly over the observed region.